In the AI world, it's always felt like this race for size, right? Bigger models, more data, more computing power. But what if that entire approach is, well, wrong? What if a smaller, smarter model could not only keep up with the giants, but actually beat them at their own game? Okay, let's dive into this. Because a new system from NVIDIA called ToolOrchestra is doing exactly that, and it might just change everything.
And this is really the central mystery, isn't it? It sounds almost impossible. I mean, an 8 billion parameter model? That's practically a rounding error compared to the massive frontier models we hear about every day. So how in the world could it possibly come out on top against something as powerful as GPT-5? Well, the secret sauce here isn't about brute force. It's all about working smarter, not harder.
And look, you don't have to take my word for it. The proof is right here in the numbers. There's this benchmark called Humanity's Last Exam, and trust me, it's designed to be a beast for AI. And right there, you can see the smaller Orchestrator 8B scoring 37.1%, just sneaking past GPT-5's 35.1%. The data doesn't lie. A smaller system got a higher score on a seriously tough test. To understand how that's even possible, we first have to talk about the big problem with building these giant AIs.
So let's get into what's called the monolith problem. You see, for the longest time, the mantra in AI was super simple. Bigger is better. The whole idea was to build one enormous AI, a monolith, and just train it to do absolutely everything. But that philosophy is starting to show some pretty serious cracks. So what we're really looking at here are two totally different philosophies. On one side, you've got the monolithic system where one giant brain tries to solve the entire puzzle all by itself. But on the other side, you have an orchestrated system, and here a smaller, much more nimble conductor doesn't try to play every instrument. Instead, it's like a smart conductor who knows exactly which specialist to point to for each part of the problem. Okay, so here's where things get really fascinating. These huge models, they have this critical flaw that the researchers call self-enhancement bias. What that means is when you give a giant AI a choice of tools, it has a huge bias towards using, well, itself. It's kind of like a master carpenter who insists on using a giant sledgehammer for every single job, even when a tiny, precise screwdriver is what's actually needed. And get this, just look at the data. When GPT-5 is asked to be its own conductor, a staggering 98% of the time it calls on itself or its smaller version. Only a tiny 2% of the time does it reach for other tools that could be better or cheaper or faster. This is just incredibly inefficient, and it highlights the exact problem that ToolOrchestra was built to fix. So this is where our hero finally enters the story. The orchestrator isn't a soloist trying to steal the show. No, it's a conductor, and its only job is to make the entire orchestra sound brilliant together. So how does it actually work? Well, take a look. The orchestrator model sits right in the middle, acting as the brain of the operation. It's coordinating this whole suite of different tools. You've got your basics like web search and a code interpreter, but you've also got specialized math models and even access to powerful AIs like GPT-5 itself. The orchestrator's only job is to look at the problem and pick the perfect tool at the perfect moment. It does this with a really simple but incredibly powerful three-step loop. First up, it reasons. It looks at the problem and figures out a game plan. Next, action. It picks the best tool for that step and calls it up. And finally, observe. It takes the result from that tool and feeds it right back into the loop to decide what to do next. It just keeps running this cycle over and over until the whole problem is solved. But of course, this brings up a huge question. How do you actually teach an AI to be such a smart manager? I mean, you can't just tell an AI to be better at delegating, right? You've got to train it. And the secret here is a technique called reinforcement learning. Essentially, it was trained by being thrown into thousands of complex, multi-step problems. It learned just like we do, through trial and error. It got rewarded for making good choices that moved it closer to the correct answer, and it got penalized for bad ones. Over time, it just got better and better until it became an expert at delegating work in the most efficient way possible. And this is where it gets really, really clever. The rewards weren't just about getting the right answer. No, the system was trained on 3 different goals all at once. First off, the outcome. Did it actually solve the problem correctly? Simple enough. But then there's efficiency. How much did it cost in both time and money to get that answer? And third, and this is super cool, preference. Did it actually listen to what the user wanted? Like if a user prefers privacy and doesn't want it to search the web, the model gets rewarded for respecting that wish.
So, all that fancy training, does it actually pay off? Well, let's look at the proof because the results are frankly incredible.
Okay, so let's circle back to that humanities last exam benchmark. And yep, as we saw before, Orchestrator 8B is sitting right at the top of the leaderboard, beating not just GPT-5, but other heavyweights like Claude Opus 4.1 too. And this isn't some one-hit wonder. On a different test called Frames, which is all about factuality and solid reasoning, it wins again, pulling ahead of GPT-5. And just to really drive the point home, on a benchmark that tests its main job, choosing the right tool for the job or function calling, it comes out on top yet again. This really proves that it's an expert conductor, knowing exactly how to manage its orchestra of tools. But here's the real kicker, the part that should make everyone sit up and pay attention. It's not just about getting higher scores. It achieves these better results for a tiny fraction of the cost. This thing is in a league of its own, delivering more performance for every single dollar you spend. It's not just more powerful, it's fundamentally smarter. Let's just put a hard number on that so it really sinks in. On average, using Orchestrator 8B to solve these tough problems costs only about 30% of what it costs to use GPT-5. Think about that. You're getting better results for 70% less money. For anyone actually building stuff with AI, that's a total game changer. So when you step back and look at all this, it's pretty clear we're not just talking about one cool new model. This is hinting at a massive shift in how we should even be designing AI systems in the first place. You know, one of the NVIDIA researchers put it perfectly in this quote. We're seeing a shift away from these monolithic models toward what they're calling compound AI systems. The idea is that instead of one giant brain, you have a team of specialists that are modular, adaptive, and can even optimize themselves over time. And that leaves us with one last big question to think about. For years, the assumption has been that the path to smarter AI was just to build bigger and bigger models. But maybe we've been looking in the wrong direction the whole time. Maybe the future of AI isn't about building the world's greatest soloist, but about training the world's smartest conductor.